Hi, this video is about binomial probability. I'm going to quickly go through some theory, give you 4 examples, and then show you how to do some of this on the calculator. I'm using a TI-84, but it's similar on most calculators. Binomial probability means there are 2 possible outcomes. Bi means 2, binomial 2 terms, 2 possible outcomes. This is things such as all those, and so either it is 2 possible things or you set it up so that's 2 possible things. Good example, win-lose. Probably better to say win, not win, because maybe you could draw as well. So 2 possible outcomes. Most of the questions are set up like this. You do so many trials. What is the probability you have so many successes? They'll tell you what the probability is for one trial, but you've got to translate that into a number of repeated trials. What's going to happen? What you've got to ask yourself is how many ways can this success, how many ways could it happen? And that's where we use a thing called Pascal's triangle, or we use combinations. Now, hopefully you've seen this before. If you haven't, I'll put some other links down below of videos you could get to see that. We'll try and mention a few things as we go. Okay, this is called combinations, and you might see it written like this, like a vector. It's not a vector, but it looks like a vector. Or NCR, written a few different ways. And what it is this little formula here, factorial, but all the answers are actually contained in that Pascal's triangle. This tells you how many different ways can, when you do n trials, how many different ways can you have R successes. So here's the idea. If you do 4 trials, how many ways can you have no successes? Well, there's only one way, fail, fail, fail. How many ways can you have one success in 4 trials? Well, you could have the success the last time, the third time, the second time, or the first time. So there's 4 different ways that can happen. How many ways can you have 2 successes? Well, there they are. There's 6 different ways. How many ways can you have 3 successes in 4 trials? Like that. So it's the same as 1 success. And how many ways can you have all 4 successes? Well, only one way. And you'll see these numbers here, 1, 4, 6, 4, 1. That's these numbers here, 1, 4, 6, 4, 1. Okay, how many ways can you have 3 successes in 6 trials? So 6 trials, so we look down here on the 6th line of the triangle, and we count from the left, 0, 1, 2, 3, and that's 3 successes in 6 trials. 5 successes in 7 trials, so start here, 0, 1, 2, 3, 4, 5, 21 ways. 8 successes in 8 trials. Well, that's similar to the before. You can kind of logic that, but if you don't want to think about it, just start here. It goes 0, 1, 2, 3, 4, 5, 6, 7, 8, and you get there. Okay, 3 successes in 8 trials. Okay. Again, that's the 8th. Start at 0, 0, 1, 2, 3, 56 ways. Now, 35 trials. I can keep my Pascal's triangle going, but I'll be here till Tuesday. So what we need to do is find a better way to do it, and that's using your calculator. So you'll find somewhere this NCR function, and you'll put in 35 for N and 20 for R, and that tells you there are 3,247,943,160 ways of getting 20 successes in 35 trials. Okay, now, next step, what if the probability of success for each trial is 0.7? What's the probability of 0 successes in 4 trials. Well, we're going to go 0.3 to the power 4. Now 0.3, because that's 1 minus 0.7. So 0 successes means 4 failures. So these are 4 failures to the power 4. Okay, 1 success in 4 trials. Well, 1 success, so 0.7 to the 1, 3 failures, so 0.3 to the 3. But there's 4 different ways that can happen. So 4 times 0.7 to the 1, 0.3 to the 3. Okay. 2 successes means 2 successes and 2 failures, so it's 0.7 to the 2 and 0.3 to the 2. But there's 6 different ways that can happen, so we've got to times it by 6. Similar with these. Okay, 4 ways you can do it. 4 ways you can have 3 successes and 1 failure. There's a 1 way you can have 4 successes. So you see the connection between the triangle and the probabilities now. What we just discovered there with this little thing is a formula like this. So you did the combination, the probability of getting exactly R successes from N trials. You worked out the number of combinations of R successes from N trials. You did the probability of success to the power of the number of successes, probability of failure to the number of failures. This N combination R you can find from Pascal's triangle or from your calculator. Okay, so now we'll look at a worked example. Now this is in the next 3 days, the probability of rain is 90%. What's the probability it will rain exactly 2 out of the 3 days? Well, we're going to use this formula. N equals 3 because there's 3 days. P is the probability of success. In this case, success means that it rains. Okay, so 90%, so 0.9. This question is asking exactly 2 out of the 3 days, so R will equal 2. And then we just put that in our formula. Put in your formula, or you can use your calculator 2 different ways. This here, combination 3 combination 2, is the number of ways it can happen 2 out of 3 days. This is probability of success on 2 days and failure on 1 day. So it's pretty logical formula when you really think about it. Okay, so if you have a calculator, you can input this information like that, or most of the calculators have this binomial PDF formula or function, and you can just put the values in and it'll spit out the same answer. Okay, have a little explore on your calculator, see if you can find that. Now let's do rain on less than 3. So less than 3 means 0 or 1 or 2. So you'd have to find the 3 of them and add them up. Or just remember that less than 3 means not 3. So what we're going to do is do 1 minus the probability of having raining 3 days, and that's what that is. Okay, so you can either work that out logically, like I've done, saying less than 3 is not 3, it's anything else, so it's 1 minus probability of 3, or we can use this binomial CDF formula. This is C for cumulative, that means it's less than or equal to 2, so 0, 1, or 2. So again, explore that formula on your calculator. It's probably at least 2 days out of the next 3. At least 2 means 2 or 3. So you've got 2 and you've got 3. So you add them together and you get 2 or 3. You can also use the binomial CDF. That means less than 1. So 1 or 0. So this is not less than 1. So you have to use it like that. Okay. Billy just doing multiple choice test with 8 questions. There's A, B, C, or D. So that's 4 choices. So the probability of guessing correctly is 1/4, which is the first question. So any particular question is 1/4. So no particular questions means that he's going to get them all wrong. So it's 0.75 to the power of 8. Getting exactly 4 questions. So that means 8 combination 4, 0.25 to the power of 4. So this is guessing correctly to the power of 4 and guessing incorrectly to the power of 4. Okay, and that'll give you your answer there. Again, you can use binomial PDF because it says exactly 4 questions and get the same answer. Explore that on your calculator. Question D, more than 6 questions. So more than 6 is 7 or 8. So you've got to do 7 plus 8. Okay, the probability of getting 7 and the probability of getting 8. Okay, so 7 is 8 combination 7. 7 right, 1 wrong, plus 7 right. 8 right, sorry. 8 right. And you work that out and you get that. Okay. Again, you can use your binomial PDF. Remember, if your calculator says this, e to the negative 4, that's times 10 to the negative 4, so it's 0.0003, or 81. Okay. Another example, population Melbourne is 30% Greek. A jury is selected from random citizens, 12 people in the jury. What's the expected number of Greeks on the jury? Well, 30% of 12 is 3.6, so we'd expect 3.6 jury members on average. Of course, you can't have 3.6, so that's why we asked the question B, what's the probability of getting exactly 3? So exactly 3, we got R equals 3. Just put it in our formula. So 12 combination 3, 0.3 to the 3, 0.7 to the 9. Okay, once again, it's the number of ways you can get 3 out of 12. Probability that they are Greek to the power of 3, because there's 3 of them. Probability that they're not Greek to the power of 9, because there's 9 not Greeks. Okay. Again, you can do that with binomial PDF on your calculator. At the most 3, that's 3 or 2 or 1 or 0. And the best way to do that is with CDF on your calculator. You can also work out this formula for 3 and 2 and 1 and 0 and add them together. Okay. Last example, we got swine flu and 25% of people as students are sick and they have to stay at home. Every class in the school normally has 20 students. Find the expected number of students in class who are each sick. So that's just 25% of 20. The expected number. What's the probability that 6 students are absent? Well, R equals 6, and we just use our formula. 20 combination 6, 0.25 to the 6, 0.75 to the 14. Again, that's 6 students sick, 14 students not sick, and the number of ways that can happen. Or use binomial PDF on your calculator. Okay, if 40% or more of the students are sick in the school will be cancelled. What's the probability school will be cancelled? Okay, 40% or more of the students means R is greater than or equal to 8. 8 out of 20 is 40%. So that's 8, 9, 10, 11, 12, up to 20. So you could do those, 13 different calculations. Or you can do these 8 different calculations, including not 0, and add them together. I use binomial CDF, so the fact that I've got 0 here doesn't really matter. There you go, now it's fixed. All right, so make sure you have a go with your calculator, see if you can work out how to do PDF and CDF on your calculator, and good luck solving these questions.